Have to start in a second.
I hear you guys finally changed up the announcement slides.
Yes.
It's not my face on it.
Honestly, I really thought about just keeping it so much.
I kind of want to change it back next week.
Yeah, I got the picture. We turn it back.
Just to make it the negative of that picture.
Yeah, I'm gonna make a background just AJ's face.
All right, I'm gonna go ahead and get started, guys. Welcome to meeting 87. I'm Cliff, and I'm the president, and we're doing today the RevUC CTF that we hosted this last Saturday through Sunday. We are going to do a walkthrough of some of the challenges from that, and yeah, thanks for coming, everyone.
Hey everybody, I'm Robbie, I'm the secretary as usual. Just gonna go through announcements. As always, if you're new, join the Slack. Slack's kind of the heart of the organization, so if you need any updates or whatever, they're gonna be posted in the Slack. Can't stress that enough, join the Slack. It's a pretty chill environment. Announcements, not a lot new this week. As always, we got our bi-weekly lab events, and we are looking for more hands if anyone wants to help out with the lab committee. Anyone that just really wants to help or knows anything about hardware or lab as a whole, speak to Ryan here, head of the lab committee. And when's the next event going on, Ryan?
Next event, so Monday, we don't have like a confirmed topic yet, but we're thinking byte patching. So if you want to modify binaries and see what happens to the binary, come Monday, but it's not confirmed yet. So stay up to date on Slack.
Yeah, look on the Slack. Okay, we had RevUC UC on Saturday, a whole lot of fun. We hosted the CTF, obviously. I think that went really well. A lot of people there. I thought that was pretty interesting to see everyone go through it. So, hats off to the CTF guys who prepared that. Good job. And really, that should be about it. Other than tomorrow, if you signed up, we do have our first dodgeball game. So that's going to be sick. It's not going to be a game so much as a win, guaranteed win.
Did we talk about the outreach?
Oh, yeah, we have the outreach event coming up. I believe that is for Loveland.
Yes.
Yes, Loveland. And we got that date confirmed, right?
Yeah, that's this next Wednesday.
Yeah, March 13th.
Yeah, so I'll be there. I think Mike's going to be there. Chris might be there. If anybody else wants to come, you're more than welcome. We're going to have a good time. Probably going to get some food, talk to the high schoolers about cybersecurity.
If you need service hours, Franco will also sign up for service hours.
Yeah, so definitely go to that if you need more service hours.
So
never say no to that.
Post something in Slack if you have any questions.
And that should be it for the week. Not a whole lot new, guys.
Get it, Chris. Thanks, Tim.
It's me. All right. So last night at around 9:30, NSA released a Ghidra. If you don't know what Ghidra is, and you know what IDA is, it's IDA, but the NSA made it. Ghidra is basically just another. Well, it's not just another. It's a software reverse engineering tool. It's been developed by the NSA for, I think, about 15 years now. Was the estimate for a couple $1 million. And they released a full version of it last night, around 9:30. It's available on ghidrasre.org. Software reverse engineering is what SRE stands for. I've already pulled a version of it into our GitLab, so if you want to work on it there, so we can all use it. The version on there does run. I think it uses Java 11. It's pretty weird. Yeah. It's definitely worth checking out. It looks like it can convert between IDA or can import and export IDA projects pretty well. I was up until like 1 in the morning reading the manual. I haven't really gotten too far into it though. It's pretty big. There's also, AJ, is there intermediate language support on that?
I wouldn't call it intermediate language support. I haven't really played around with it a ton, other than just reading the docs since it came out last night. Yeah. But I do think the fact that it does show you the C code, it'll try to show you the C code of the assembly that you're working on is really fucking cool.
Yeah. So this was demoed last night and also today by Rob Joyce, who is the head of NSA's TAO at RSACon, which is a big thing happening right now. All right. So that's it for weekly news. We're going to jump right into the CTF review. So if you don't know, we actually made a meta tool for making CTFs, but it's not really as important as going through the CTF problems today. So if you have a laptop, Get it out. CTF good. If you were on here before, you'll have to re-register because I wiped the whole thing fresh. Some people had already solved a lot of problems. Alright. So this is what our CTF looks like, if you hadn't seen it on... Did anyone not go to the hackathon and not see the CTF? Why? That's fair. Alright, so we have, I believe, 12, 15 challenges on here. It's a weird number. The phone section is all about exploitation of binaries. The malware analysis is 3 malware analysis problems from the homework here at the UC. Those are all the homework too. Some people already had that solution. And then we've got reversing. We have 3 problems. One of them is goats, which we've covered a couple times already. Leg is actually an ARM problem. It's a funny joke there. And REasy is just another, I think it's ELF86. Forensics, we have 2 forensics problems and 1 cryptography problem. Does anyone want to start anywhere specific? Which one? Secret messages 2. We gotta start with secret messages 1. Alright. So if you had any problem, you should be able to just download the zip. It's a sequential problem, so we need to start here. It's somewhere. Dear CTF. Correct. Alright, so we get our CTF problem. There's a zip file. Go ahead and unzip it. Let's go ahead and open it and try code. You guys can't see this. Alright, so first thing we see when we open up secret messages is just a stupidly large amount of data.
Yeah.
Can I zoom in on this? No. Yeah. So what we can go ahead and do is scroll down to the very bottom of it. It's going to take forever. Alright, so we see an equal sign at the end. It indicates to us that this is probably base 64 encoded, which we can go ahead and test. Close that. Linux base 64. Never run this before, you just do help. We want to run with a D parameter to decode our data, because this is encoded. Code 1. Back over here. Alright. So when you open that back up, the first flag is right there. That's for secret messages 1. Take that out of there so we can keep going through here. If we want, we can actually shove that into CTFD. Nice. Okay.
Following along all right?
You guys got it? So if we open that back up, obviously this is still a large amount of obfuscated data, but if we go to the very end, we don't see an equal sign. AJ, did we just decode this straight, or do we have to add an equal back to it?
So this next step, we're gonna have to do a lot of decoding. Base 64 decode like
8 more times.
like it's 9 times. So
Okay.
a quick Python script
Yeah.
would probably work, or just B64 decode to a file. Just keep reading that file.
I'll just do the second one. It'll be easier.
You have my write-up, right?
I do. I don't want to open it. Valid input. Uh-oh. It's worse. Oh, I know what I did. So I opened that up in code. The whole base 64 message was actually on a single line, and then if you saw, I removed the flag and then I hit save in Visual Studio Code. It didn't support how many characters were on the line, so we got to do this in something else. We'll just do it in Vim. Yeah. Oh shit. Not gonna do that in Vim. This worked last time, I think. Oh, it still ends in 9. So you could write a Python script for this. I'm just going to do this the dumb way. So you guys can follow a little easier. You guys read that? No? Alright. That's close enough. How many times do we have to do this, AJ?
Like 9 times, 9 or 10 times.
Oh, I didn't like that. Alright, we'll do it until it gives us an invalid file.
I would check when you get to 8.
Alright.
At least check it. Yep.
Yeah, we got one more to go. Oh, Christ. Alright. Okay, so...
Probably have to go more.
Yeah.
Maybe.
Maybe?
Let's see.
I think it only goes to 9. Oh.
Yeah.
Okay.
This looks correct.
Okay, so it goes 10 times, which is garbage.
9 if you count 0. Right? Yes.
Yes. Okay. Alright, do you have an easy way to do this through command line, or do I have to remake that whole Python script?
Just do head.
Head?
That file.
I mean, like the next part of it.
Yeah, so we can see, so we can really see it. It should bring us to the top of it, and it should say bytes XOR, or just name
So that's it. Alright, so we open up our newly... Yeah. Oh shit. Okay, so byte XOR. If you don't know what that means, XOR is an operation you can do at binary level. Looks like it's been done per byte here. Right, AJ?
Yeah, it's for one. It's a 1 byte XOR. That's the key. It's 1 byte.
All right.
So we need to delete that for sure.
Okay.
That 1 byte XOR up to the first character.
Do I delete the space?
Yeah.
All right. All right. You wrote a Python script with this, right?
Yeah, I did.
You share it with me, so I don't have to remake it.
Yeah,
So basically, we need to go over this file and decrypt the whole thing using a bytes XOR key. bytes XOR only has 256 possible combinations, the possible values in 1 byte. So this is pretty trivial to brute force. I just don't want to remake the function to do it because AJ already has it. There's a tool, I believe, called Cipher Tool. Let's see where. Or we can just Google it. It's not a hard operation. Yeah, so there's a tool called Zor Tool on GitHub, which we can use to do this. I don't know the syntax, unfortunately.
You don't want me to just
Yeah.
use some code?
If you just send me the code, AJ, that'd be appreciated.
You're gonna have to put it into a Python file.
I can do that.
Yeah, so when you get this bytes XOR object or anything that kind of looks like that format, just kind of jumbled up, it's kind of safe to say that it might be a XOR object. So typically, if you get something that doesn't look like hex, doesn't look like base 64, you know, brute forcing an XOR is not a bad thing to try. So while he gets that code up, when you do brute force an XOR, a bytes XOR object, you want to check for an output with the most human readable characters. You want to be able to look at it and have it not look like another bytes XOR object, if you know what I'm saying. You're kind of following it. It should not look like that mess that he had up there. It should look like A's and B's and letters and numbers and shit we can read. Typically in CTFs.
Alright, let's go.
And this problem, this is definitely not the easiest of problems on the CTF. It's just one of the harder ones, I would say.
Okay, so AJ just gave us this. I'll show you on the screen.
You got it.
I got it.
I have it set to open certain files, right? Yeah, so we need to untab the second definition and just have it call itself. They were both inside a class too, so.
Alright, we can all see that?
So we probably have to take out the selves too, unless we want to dump it inside a class. You know?
No, that's fine. Alright, just modify your data. Uh-oh. That's fine. Does anyone not follow what's happening right here? Alright, good.
So I mean, what's happening, if we want to explain it, it's opening up that file which I named homework2.64 loop. Do y'all see that on line 13? For us, that would be called whatever the file he has is decode 10. So I'm opening it, I'm reading it, and I'm reading it in as in file. And then I set that data in that file, and I read it into the data variable. And since it's a 1 byte hex XOR, there's 0 to 256 possible values that the key could be. So I open a bunch of temporary files that are called temp and then the number of the key I'm trying, and I write the XOR data into that file. So basically, I'm creating 256 temp files, all that have decoded data in it. And one of those 256 files is the file that will get us onto the next step.
AJ, all your quotes are not Unix. I have to fix every single one.
You don't have to. Oh wow,
I
that's
do.
just how Slack copies it over.
Oh, it's in Slack?
Yeah, because in mine it's not that.
It's too late. I already got them all. There. Yeah, we look good. Alright. We're using.
Well, next one. They were both in. They were both in.
What? Who's that?
They said you're doing great, Chris. I think she was joking.
Yeah.
Oh, she was joking. That's not very nice. Alright, that was Sam, yeah. What room was she? Next flag is Chris is a failure. No, I'm just kidding.
So run that.
Oh, I didn't like that. Is this Python 2?
Yeah.
Upgrade to Python 3,
Crap,
AJ.
Python 2.
Everyone boo AJ real quick.
Python 2 is good.
There we go. It's out of date.
I'm stuck in my ways.
Did it do anything?
You check your file, ls. Did it not do anything?
No.
Oh, well, it's because it's not opening up your file.
Oh, it's because it doesn't have anything telling it what to do. The function is never run.
Oh, yeah. I gave you the 2 functions. Yeah, make it if name equals main.
I don't even need that.
And you could probably delete that whole try except thing right there.
We just do Zor or brute force.
Brute force, brute XOR. Because it calls XOR.
You don't even need to like wrap that.
And make sure you're opening decode 10.
Yeah. Okay.
There's 256
I should have done this with
files,
subdirectory.
baby.
So this is going to chunk away, and I believe the logic in there is it's looking for the word flag but encoded in hex, because that's what this is dumping out is just hexed out.
Might not work.
It might not work.
Might not work.
Unfortunately.
Okay. Well, what if it fills your disk?
256 not going to fill her disk. Not this one.
Okay, it stops.
And didn't find it, but
It didn't work, but let's.
it did work if you go to the 45th, or you could grep thermal.
Yeah.
For flag and hex.
God, flag and hex. I don't know what that is. Python.
Oh, we'll have to base 64 decode one of them, and then I'll give us hex that we can search for flag.
Does this work in Python 2?
Yeah, because it's going to be a base 64 encoded. We're not going to be able to search hex.
Okay. So we're looking for these characters in. What do you say?
We're
Is that
going to
gonna
have to base 64 decode one of those files. So the next step on this guy would be to find out of all of these files which one has the highest percent of human readable characters.
Which is apparently none of them. Shit.
And to save time, for the sake of time savings, that's the 45th file.
Okay.
Or the 69th iteration.
Oh, it found one.
Holy, it did?
Oh wait, no, that was one from earlier. Lists. Temp 78 has the word flag in it apparently. So we're going to open that one. It's not the one I expected it to be.
The flag should be in
It shouldn't be in that one because we've done this before.
It should be in the 69th iteration.
110 also had it. Okay.
The thing is
I'm curious now. I know those aren't the ones we're looking for, but I want to know. 78. That's not readable. Do we have to decode this from hex, AJ?
look at that. That's base 64.
No.
See how clean it is? See how clean and formatted it is? I'll open up any of the other files and you tell me if those look any different.
Yeah, that's
right?
all. Oh, God.
That's how you tell if you got the right one. Temp 69, haha, is the is the right one. So now we got a base 64 decode temp 69.
If you didn't know that, you could iterate through all of them and look for any kind of known data structure. Base 64 is obviously just a bunch of 64 encoded and then equals. So probably could have found that pretty easy.
Why didn't you find flag in temp 69?
I don't know.
Because it's base 64 encoded.
Yep, then you search for the base 64.
We searched for
Which one was
the
that in?
hex encoded flag.
All right. Oh,
But in a base 64 encoded block, it will encode the entire thing. So you couldn't like encode only flag and search for that in another base 64 encoded block of something other than flag.
yeah, it's probably just coincidence. So let's punch that in. Oh, I didn't even find it.
Well, no. Did you do base 64 decode on?
Now this is 78, which is one of our false positives. What was the other one? 110? Flag? Nothing. That's
Yeah,
weird.
Base 64 decode 69, temp 69.
Yeah, I'm doing it.
And print that to the next file.
Got it.
Nice job.
Then we'll dump that right into decode 11. Invalid input.
Oh, so yeah, this is another thing I found out.
Oh no, it's not.
Oh, it worked.
Yeah. Okay. So that's obviously human readable, right? Well, maybe not. Let's open that.
It's definitely human readable enough.
Oh, where'd it go? Okay, so if we look in this, we can see. Say a JavaScript object, or not even an object, just a function with a variable in it. And that's a hex, right, AJ?
That is in hex. See,
Okay.
you can tell if real of you are looking at it might not know how to see, hey, that's hex. It's just, you get the eye after looking at hex and base 64 for so long, they call it the analyst's eye if you're analyzing malware and stuff.
How
But
big is
you
this
can tell
file?
this is hex because of all the FFs, that nothing higher than F.
We can also do one other thing to check if this was hex. If we go back to our previous grep command,
Damn right.
there's all the 6s. You can see our decode 11 has flag in it twice, but in hex. So that's stuff to look out for in the future.
So we have this function.
Alright, where'd the function go?
What do you guys think we do with this function now?
Alright, you guys lead. How do we get this object out of this JavaScript function?
Right here, run it.
I'm not running this.
No, we run it.
I don't want to run this. Okay.
So you're running. So you go to Chrome DevTools.
Put the function in your browser.
Are these all different objects?
It's the same variable for a lot of them, except for that.
Those are different.
So, but the trick is you copy this whole thing,
Yeah.
and you go to Chrome browser, and then you open up DevTools,
Alright.
and we gotta paste it in there, or anything to run JavaScript. We gotta run this JavaScript in
So
console.
does that say delete this, or am I just...
Don't delete it.
Just this line? Okay.
Kellic.
Alright, I'm going to save this as an HTML file. HTML. We'll just open it in Firefox. Oh, I didn't like that because it wasn't a script tag. Is this how you did this, AJ? Or
I actually just straight up copied it and pasted it into Chrome DevTools,
oh shit.
and then just added console.log, and then I logged that variable that keeps appending shit to it, the 48G.
Okay.
So at the bottom of it, so
Yeah,
inside,
I'll just add that right here. Oh, wrong way.
yeah, right there, I console.log, and then that last variable, X and D, yeah, that guy.
Oh, we're all good.
Yep,
Alright.
console. Yep, condole.
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 That's what I wear. Alright. We'll do this in Google Chrome though. Because I know how to use those tools. Decode 11. Oh, that's not real. No, not in the right directory.
You're doing it differently than I did. I just opened up the browser.
Alright.
That was a lot less. Yes, and
Sweet.
then, yep, and then
Jump into our browser, there's nothing on this page. But if we go into our console, our object has been dumped. You can't really see that very well. There's a nice copy button right here. Recommend. You could also dump this into Node and then dump that into a file if you knew what you're doing. Don't know Node, so I'll do that. Okay. New file. Oh, go back.
So you get that hex file, now we get a hex decoded.
Yeah. Alright. 2 hex.
I have a decoded hex function I can give you.
I think there's one built into Python. Decode hex. I can't see that. I'm saving this as decode 12, just for everyone's awareness.
So let's try, and how do you pipe it in from the file?
Just whatever your file is.
Let me see if I can do this in Python real quick.
I'm gonna send you something, Chris, too.
Okay.
In case you want it. That's that.
Nah. Let's do that.
You guys kind of following along? So processes like this, though, is similar when analyzing malware. So you guys ever get a job where you're working as an analyst and you're given a malware sample? A lot of times, how malware bypasses modern-day antivirus solutions is by obfuscating itself and doing stuff exactly like what we're doing here. Base 64 encoding its payloads, you know, having another harmless function like JavaScript build a hex, which is its payload, you know, and then obfuscate that JavaScript. So, I mean, that's a lot of times how malware sneaks by.
A decode 11 down? Yeah, decode 12.
So like some encoding, like basically for like taking some through that's actually malware, so just encode itself with something else that it doesn't pick up.
A lot of times that's all it takes.
It rebuilds itself.
Yeah.
Or transfers it, decodes it back to what it's supposed to be.
Exactly. A lot of times you'll get a payload. It'll be delivered and it will be like running PowerShell, and it will be a PowerShell command that itself is like base 64 encoded, and then it decodes that itself, and then it decodes some other form of obfuscation, and then eventually it builds its payload and then executes it.
Alright, AJ, what's going on here? You didn't like something I did. XE2.
Well, go to the.
Go to the what?
Go back to the Python script, and make sure it's all tabbed right.
Oh,
I don't know.
I see what it is.
Oh, and we also have self.
It's Slack is messing with all the quotes.
Are those quotes you're putting in there?
Yeah.
Backticks.
Oh, these are backticks. What am I doing? Can't really see. So you know, AJ, you can put raw text into Slack if you tell it to.
Yeah, my bad. My bad. I'm a bad guy.
Yeah, so we're basically just reading in this file and then decoding hexit, which I guess I could have just done through the command line because it's only 2 lines. And then we're dumping that into a new file. This is good too, though. Spacing. Alright.
Challenges.
Decode hex.
It's a
One
self. Yeah,
argument.
I think we still have self.
Self? Oh, we do.
All these functions I sent him were originally in a class, so.
Yeah. Go back. Okay, so now we have decoded JavaScript, decoded JS. So file decoded JS. Data.
Data.
Very descriptive. Is there a flag in that, AJ? You know?
There is. This is how you get the second flag.
Okay.
So grep that. There it is.
So if we go through lesser vim or grep, we can see there's a flag in here.
It's right there in front of us.
Literally right here.
There's 2 flags actually.
2 flags.
The flag for the stage 2 is right there.
Is this one we want?
That's the one we want for stage 2. You can only see the beginning of the stage 3 flag.
Yeah.
But there's way more work to be done to get the stage 3 flag.
Okay. So, let me copy this out of here.
May have to decode the X inside that flag.
Do we?
I don't know.
I'll try it without it. I think we do, now that you mention it. It's still a data. Alright, let's go back to our CTFD instance and see if that's our flag. Ah! I'm gonna do this on my screen because I can't see my mouse pointer from across the room. So that was our flag, just right there. If we base decode it, I think it's just a goofy message. Alright, 3rd flag. We've got 1 more to go. I think we... What did we do to this one, AJ? Is this an image now?
Yeah, so what we have in that decoded JS is just data. And if we look at the top of it, or let's do a bin walk on it, bin walk -E. Yeah, perfect. So what does this tell us? Do you want to talk about this, Chris? Or?
So, from what I've gathered, binwalk basically goes over a bunch of data and tries to pull out file descriptors in full files from it. What we just did here was list all the files inside of this big chunk of data. So we have a JPEG image. There's obviously something else in there though. Oh, not declare, Jesus.
So we can see also through binwalk that decimal, that's the start of the JPEG. Yeah. There is 524 bytes?
Bytes before we even get to our JPEG. So we need to cut that out and then put it back together as 2 separate files. Do you know what the JPEG is?
I never extracted the JPEG because I didn't. Okay. I think it's like a cat or something. Okay. So, but this is a great example of malicious code or code hiding in a JPEG file. So if you actually catted the decoded JS and grepped for JFIF, we can see in the code itself something that tells us it's a JPEG without even running.
We can also try to pull some strings out of it. That's probably not going to work nearly as well.
You grep for JFIF.
Oh, that's not what we were.
See JFIF right underneath the 5377?
Yeah.
JFIF.
Yeah, JFIF, that's in the raw data of JPEGs. So if you see that in a file, you're like, oh, shit, this is a JPEG.
Is there a flag from earlier in there as well?
So we could do now.
So we just ran strings on that. Everyone knows what strings is, right? It just goes through a binary amount of data and looks for printable information. I think the minimum it looks for is 4, as we can see on here. Sequential pieces of printable ASCII together. This is interesting, but I don't think that's anything important right now. We'll get to that later. But if we jump down through here, everything past, I think right about this line is actually our JPEG. Or probably the order.
We don't care about the JPEG.
I want to see the JPEG if it's a cat. I have a mouse pointer here, Jesus. Alright. So we're going to give it the E option to extract all known file types from this. Did I do that right? Where'd it go? It doesn't seem to want to do it. Does anyone want to correct me on what I'm doing?
Alright, sounds good. Yeah, so, I mean, I would just, I never bothered to extract the JPEG. That's something that we can do another time with the tool. If you really want to get it, we could go through and try to get it, but we can try to get the third flag if you guys want to see that.
You guys want to go to the third flag, or do you want to do a different challenge? We have time to do one more if we want to flip.
Let's do this.
Different challenge? Okay.
Yeah.
Enough of this.
It's a harder challenge.
So that's flag for the third one, which is in the JPEG data.
It's not in the JPEG data. It's in the code hidden in the JPEG.
Yeah, so if we go further, there's actually like an actual binary embedded in that blob of text, and then if we were to basically step through that, we would be able to see it constructing a flag in memory, right?
Yep. It literally, in the first 524 bytes of the JPEG file, they have shell code encoded as hex in those first 524 bits. You have to extract the shell, you have to extract the hex, convert it to shell code, and then run that shell code in a C program that's called a shell code harness that will execute the shell code, and then you have to watch it run live and watch one of the registers, and then you get flagged.
Yeah, we're not going to do that. All right, what's next?
You would have solved that.
Who wants to do the next one?
Does anyone want to do the next one? Feel free to shout any of these out. I think Caesar Cipher is pretty easy, so we'll just skip that.
What the forensics?
Forensics?
While on
Which forensics?
You spent a while on which one?
Python one,
Python one. I'm not going to do the Python one here because I don't want to explore through the whole Python library, but I can just kind of show you how it would work. So that was in Python 2. Oh, shit. It's just muscle memory. But if you don't know, you know what, I should probably run this anyway. Let's jump back. Sorry. So if we go to Python jailbreak, it gives us the source code. And the source code basically dumps every single built-in from the Python working set. I don't have a word for that. Enhance. Okay.
Enhance.
This is actually from Played CTF, and then I believe Aaron McCanty actually made this way easier because this is a freaking insane problem. So the challenge is to get a shell, and then wow one. So we enter this input loop. Right up here, we import modules, which is literally all the Python modules that we have available by default, and we clear them. So we have no modules imported into Python, and then we delete the modules handle. If you don't know what that does, it basically keeps us from importing anything, which is really fun. And then we define two function pointers, raw input as raw input and eval as eval. What those two put together will do is raw input will take in a string from the console, and eval will run it as a line of Python code within the program. And then all the built-ins are deleted, and then the built-ins, like the handle itself, is set to none. So the point is to break out of this class and get a shell. If we look in here, it takes the raw input from the command line, and it runs it, and then it spits out the result. So if we actually connect to the server, which should hopefully be up, that'll be sad. Okay, so this is actually running on our CTF server. We can do what, and then it says what is not defined. So what that means is what is actually being shoved into the Python interpreter. So we can start with different things in here. We can see that numbers are evaluated. So this is the first step you have to realize, is that it's like literally just taking whatever you take and shoving it into the Python interpreter. But we have no built-ins. But data types are not built-in. So we can evaluate lists. And I don't think we have deer. It'd be too easy. Yeah. So if you know anything about Python, you know about double underscore methods, or dunders. Oh no.
We're at Python 4 now.
Whoa! So we can basically navigate through classes with double underscore methods. It's a little, I want to do this in Python 3, even though it's a little different. It'll actually run on my shell. I don't know why it does this. Or no, it won't.
It's Python 6.
So we can kind of tab through all the double underscore methods. I'm not going to go through the full example of this, but basically we want to go to base class.
Yeah, it's in the Python file. Like
Base. Oh, it's base. Yeah, thank you. No, that's not right. Class. Base. Double underscore. And basically from this we can get to objects, and after that we go to subclasses, plural, which is returns a list of all the basically all the built-in classes in Python, and we can actually see this will run on our class. Base objects. So basically we can navigate through this shell and then come back to this one just to make it easier on ourselves. The objective from that one is kind of weird. You have to know the Python language really well. If you pivot from this into the error base class, exception base class, one of the IO exceptions actually keeps a handle onto, I think, both OS and system through one of its print methods of all things. And then you can give it, once you have OS, you can do os.system, which is just a shell call. And then you can call bash. Does that make sense? I won't give out the full answer, so you can challenge yourself with this hint. Yeah. Do you want to do any other ones? We'll do one more at most. Cone 1? I'm not doing cone 1. It's the broken one, isn't it?
No, that one works.
Oh, that one works?
Yeah.
I still don't want to do it.
Okay.
Alright. These ones, all the other ones are either shellcode or exploit based. I don't really want to go over the next 10 minutes, so we'll hit. Which forensic should we do? I'm not doing leg.
Leg's gonna take a while.
Okay, so leg is in. Have you guys seen leg? All right, prepare to be shown, because it's literally in ARM assembly, and the easiest way to leg.c. The easiest way to solve this problem is literally to change this source code to print out the results of all the keys, and then to compile it and run it on a Raspberry Pi. Yeah, so now you know this secret. If you just do put string key, it'll dump the whole thing to the console, and then you win. Other than that, if you don't have a Raspberry Pi or an ARM-based architecture available, you can try to emulate it, or you can literally run through the program counter. You can run through the entire thing by hand, which would just be a nightmare. All right. Any other questions or requests? Actually, no, we're done. That was the last one. Yeah.
What about
Trivia. I don't have the trivia up here. Hayden has it somewhere. For some reason, I tried to recover our CTFD instance to be fresh. I'll leave it up over the week if you guys want to play with this. And it literally just destroyed the trivia, so maybe I'll put that back up later. All right, we're done. Thank you.
Yeah, so I mean, I hope that gave you guys some idea on how to solve some of these problems. I think Chris did a great job.
Yeah. CTF team is not meeting this week. We'll meet next week, Saturday at 11. If you're interested in being more involved, please show up. Now that we don't have a CTF to build, we're going to go back to actually just doing them. It's a lot easier. All right. Thank you.
Sounds good.
So I think that's going to be it for this week. Thanks for coming, everybody. And if you're interested in CTF team, please come.